Well, g'day flatties and globe defenders. It's Critical Think from Down Under. Well, what we've got today here is another fantastic observation, one that totally destroys the flat earth. Having to deal with all the derp and bollocks in the comments, it gives me great pleasure to go out and do these demonstrations and observations, things that totally destroy the kind of rubbish that gets talked about. Anyway, what I have here is two images taken through a auto level and the same ship taken at different times and different distances. And we'll analyse these images and we'll show what it means for globe and what it means for flat. Now, the ship in question is the CSL Atlantic. And I've taken 3 position readings, one at 05:07 UTC, which is 3:07 p.m. in the afternoon for me, and another one at 5:23 UTC, and another one 5:34 UTC. Now I've mapped these 3 positions on Google Earth, and I've drawn the lines that I've observed. These are the observation lines, my usual observation point at Woody Point, and the estimated position at 3:17 p.m. in the afternoon there was derived by interpolating between the positions at 15:07 and 15:23, and the other position for the vessel was right in front of Tangalooma Resort there. So there's 19.75 kilometres and 25 kilometres distance. Now there I've managed to zoom right in and verify that this is indeed the ship, the CSL Atlantic. It's passing another ship at anchor there. And there's another image of the ship which was taken at approximately 15:07. Now I've calculated the height of that ship using my method of the dimensions of the camera sensor and the zoom factor and doing some pixel counting. So I've come up with a value of 43.3 metres, which is about the right size that we would expect for that ship. So here's a representation of this dimensions. 43 metres is the height of the ship above water, and this is where the 15-metre line comes on this ship. Now just remember that if the earth were flat, that 15-metre line would be my eye level because I'm at an observation height of 15 metres. So here's another picture of the ship sailing in front of Tangalooma Resort. As you can see, there's no inferior mirage to be seen. The visibility is all the way to the island. So that horizon is low, not because of a lack of visibility beyond this point. I can see all the way to the island beyond the ship. So then the question is, where is the water? If the earth were flat, we should be seeing water there. Take it away, Travis.
Okay, this horizon here, what's causing this horizon? What's causing this horizon? Why can't we see more water? Why go like water, water, water? Where'd the water go? Where'd the water go? Where'd it go? Where's the water?
That's right. Where's the water? The Earth's not flat. So as I've said before, the observer height is approximately 15 metres. Now, the auto level, I checked its calibration, and I'm going to be a little bit generous here and say that it could be out by as much as 1.5 metres. And in a 40-metre ship, That's a relatively small amount. And I say could be out. It is out by a little bit less than that, but we'll give it 1.5 metres because I haven't had a chance yet to adjust it to better accuracy, but I will do that. It's very painstaking work, but I'll do that later. That's not really important to the actual absolute position here. What's important is that it's always pointing to the same place on the same day. So here are some of the other measurements that I've put on the diagram. 24 degrees centigrade air temperature, 1020.5 hectopascals is the barometric pressure at sea level, and these are the times and the distances to the ship on those two images. So the first thing we're going to note here is that the horizon is the same distance in vertical distance from the eye level measurement from the auto level. What this means in this case is the image on the right and the image on the left have the same horizon. So the horizon is at the same distance no matter which direction you look. And this is a fundamental property of the globe. And a lot of flat earthers just don't understand horizons. They think that the horizon may move if you look in one direction or the other. They think as you go up and down in height, the horizon shouldn't move. So these things are wrong. I am at the same height, I'm looking in different directions, and the horizon is the same. And here is the evidence. The horizon has not gone up or down. It's the same. And there's another thing that you can tell from this measurement. Yes, Travis, this is a measurement. Okay, I don't have to measure the distance to the horizon, but I can certainly measure the horizon drop. Right. Now, if there was such a thing as proximal looming, and we know that's a load of bollocks, but if there was such a thing as proximal looming, the horizon should appear higher in the image to the left. The ship is further down in the water, or you could say the water is further up in the ship. So if you want to use proximal looming as an excuse for the ship appearing lower in the water, then that would mean that the water would have to rise. Or I would say appear to rise. Appear to rise because of this mythical proximal looming. But this image here with the side-by-side images shows conclusively that there is no such rising of the water. The horizon is in exactly the same place, but the ship has changed. So by the very same argument, I know this is a favourite of Ranty's, is the tsunami shoaling. Ranty will also try to tell you that the water is higher on the ship on the left because of I'll try and maintain composure here. Because of shoaling caused by some geographical features under the water that because of fluid dynamics, a hump will magically appear in the bay. Well, if that hump were to magically appear, it would manifest as a rise in the water level. No such rise in water level is evident. Between one observation and the next, they are 17 degrees apart. There's no rise in water level. No proximal looming, no tsunami shoaling. So here's another thing. Eye level is where the green line is, or within 1.5 meters of that. Due to the laws of perspective, everything at eye level should remain at eye level. But this ship has sunk. It has sunk because it is over the curve. If the Earth were flat, then the superstructure of the ship would be up at the green line on this left here, and the ship would shrink, but the superstructure would remain level with that green line, because if the surface of the water was level all the way out, the ship would not sink down. It's very simple. So, Walter Bislin has this amazing page on his website to do with atmospheric refraction. Everything you want to know about atmospheric refraction. And it is a well-known and well-studied and well-understood phenomena. So for those globe defenders that feel like they want to learn more, you should go to this site. And for those flat earthers who think we know nothing about refraction, you should go to this site and take a look. And of course, Dr. John D could benefit from some of this. Now, given the atmospheric conditions on the day, the temperature was 24 degrees, and given the barometric pressure on the day, I've worked out that the index of refraction is 0.1616, and I've used one of those formulas that Walter Bislin has published there on the previous page. And so I've calculated what the expected drop is on both locations. So there's that one and the next one, and I've marked the expected drops on the diagram. And they do fit very well with what is observed. So the drop due to curvature is consistent with the globe model. Very consistent. Just remember that on a flat Earth there should be no drop. So in summary, this is a demonstration of the effects of Earth curvature. There's no inferior mirage. There's no ether bend. There's no refractive sinking. There's no tsunami shoaling. There's no proximal looming and no angular compression. It's just Earth curve. And this observation shows that. Oh dear, Mother Nature refuses to bend to the will of flat earthers yet again. So I will go out and do this observation again. I'm going to attempt to calibrate my auto level to reduce the error in that. I'll get a wider sweep over the horizon. But in the meantime, have fun everyone, and please do share this video, like and subscribe. That's fantastic.